Welcome to our second section of Chapter 1 for our Math for Elementary School Teachers. In this first chapter, we're still discussing our attitudes about math. We're discussing different process, practice, and content standards. We're going to discuss those as well. So we're not going to be working as many problems in the subsequent videos. I'll be doing quite a bit of working problems and talking you through those problems, although I will do some of that at the end in this particular section. So we have two different sets of standards and practices to look at. The Common Core standards are being developed and accepted by many different states, and so we're going to go through those Common Core standards, and this is just kind of redefining what the National Council of Teachers of Mathematics has done. And I'm a member of the NCTM, and as elementary school teachers you can also be members of this particular club of people, because we are a club that is trying to teach mathematics. This is just a little bit of information on those Common Core standards. I'm just telling you that it's similar to what the National Council of Teachers of Mathematics uses, and then that we're going to break this down into 8 mathematical processes of this Common Core standards. And here are the 8 standards broken down into a way so that we can think about how it is that we are teaching mathematics, and we're going to go through each one. So here's the total list. Here's that list broken up into a color graphic to try to get you to associate the two numbers 1 and 6 go together, and they are kind of globally encompassing all of the practices. 2 and 3 have to do with reasoning and explaining. Number 4 and 5 have to do with modeling and using tools, which is really important in mathematics. And number 7 and 8 have to do with structure and generalizing our math problems. In Common Core Standard number 1, we're to try to make sense of the problems, and you're to kind of brainstorm as you're talking to students and try to figure out what's going on instead of just delving directly into, oh, here's how you solve it and do this. It's about making the problem make sense and making sure that your answer makes sense as well. In standard or practice number 2, we're supposed to be able to reason abstractly, meaning that we're going to make sense of what's going on with this problem, and not it just being so maybe much about one particular problem and trying to maybe associate it with a problem that might be similar to that problem, would be how we could use this particular practice. In our practice number 3, we are to construct viable arguments and critique the reasoning of others. Number 4 is one of my favorites, modeling, meaning pictures, graphs. Modeling is, to me, the way that mathematics makes sense. In number 5, we're to use appropriate tools, use tools that tend to make sense for our students. Sometimes graphing would be the only way for some students to make sense of exactly what's going on in a problem. In practice number 6, this is about word problems and problem solving and being able to interpret what's going on in a word problem, and making sure that everything that's within this is clear and concise in that problem. Math practice number 7, we're going to look for and make use of structure. Another practice where what we're doing is looking at maybe a problem that we've solved before, and can we do our next problem or the problem that we're on, can we do it in a similar fashion? Math practice number 8 is to look for and express regularity in repeated reasoning. This means if something keeps on happening, is there a shorter way that I can get to my answers, or is there a shorter way I can complete this process? Or more efficient, actually, I guess would be the better term for it. So now let's look at a problem that's similar to one that you've got in your homework, and let's see if we can solve this problem using those practices. Alright, we've got this frog here, and he is stuck in a well. So we're going to say, and I drew this little frog for you here. So we're going to say he's stuck down here in this well. Probably should have used blue down here. Just here he is stuck in there. I'm just going to say it's a deep well so I can have a little bit of room here. And we're going to say this is the top, and he'd like to get out. There's the ground up there, and he'd like to get out. I got to somehow draw it. I'm not really sure how else to draw that, but I have little trees and grass up there, so put a little grass up there, and he wants to get up there and out of this well. He's got to figure out how to do it. So what this little frog does is, let me get a better pen here. This frog is trying to climb out. Now this well is 8 feet this way. So let's say our frog is starting down here, and there's a picture of him. He goes up 4 feet in 1 hour. So let's just say here we are at 0, and then in 1 hour he goes up 4 feet. So he's now at 4 feet. Is that right? He goes up 4? Yeah, goes up 4. So he goes like halfway. Oops. Went over the top of my frog, but that's okay. And then after that hour, so this is at 4 feet, then he goes down 2. Yeah, he slips down 2 over an hour. So I'll just draw it like this. So he goes down 2. So now this is at 4 feet, and we'll just say this is at 2 feet. Trying to figure out a way to draw it isn't always easy, but it's part of the process of what you're doing. So I'm going to try and say that time is going on, and here's time right here. Time is going on. I had to do something. And that's after 2 hours. So in the next hour, he's going to climb up 4 feet. So he's going to go up 4 feet. So he's going to be at, he goes up 2, so that's going to be at 6 feet. So over the next hour, and I got this now, over the next hour he goes down 2. Well, if he goes down 2, he's now at 4 feet, isn't he? And over the next hour, at the 5th hour, then he goes up 4 more. And if he goes up 4 more, and he was at 4, he's now at 8 feet. So it takes him 5 hours to get out of this well. Okay, so I have the general idea. So let me get rid of that black line. So now I want to do the same kind of problem, but I'm climbing up 6 feet. So I don't have to draw all of that again because I know how I kind of want to draw it. But I shouldn't start the kids off drawing it exactly like this, like I'm getting ready to do, because I mean, that's not how anybody solves a problem. They make a mess of it at first, and that's really what they need to know is, yeah, it's okay to make a mess of it. So I'm going to go 1, 2, 3, 4, 5, 6, and let's see what goes on here. So I goes up 6 feet an hour. So he goes up to 6. So he's at 6, and then he goes just down 1. So he's now at 5 on this one. So that's at 5. So then he goes up 6, meaning he's now at 11. Then he goes down 1, meaning he's just at 10. Then he goes up 6 for the 5th hour, and so he's now at 16. And then he goes down 1 at the 6th hour, so that's at I did that too steep, but whatever. So that's 15. So then it goes up to 21. I'll need more room. Okay, I got myself more room. And so then at 7, 8, 9, 10, 11, I don't know how far it'll go. So then it goes down here and I'm at 20. Oh, wait a minute, I can do this from here. So if after 7 hours I go up 20, that just means at 14 hours, because I just double, at 7 I was there to 20, so I know that at 14 hours, I guess it'll be 13 because I'll get over it, so it'll be at 13 hours. I will be out of the hole. And it's going to be a little sticky there at that 13 or 14, but I can just keep on drawing it and then I would be there. And that's modeling and then making one simpler and making sure that my answer makes sense. All of those techniques. So this is problem number 7 in your homework. I went ahead and listed it up there. In this particular problem, you're supposed to make a magic square. That means when you add it up across, diagonally, or up and down, you're supposed to get the same number. So the first thing I need to do is figure out what is this sum supposed to be. So when I add all of these up, that'd be 20, 33. So now I've got to come up with the missing numbers. Now I know that this way, up and down, should also equal 33, so I know that 9 and 5 are 14, so let's just do 33 minus 14, and when I do that, I would then get 19. So a 19 belongs in here. Now one of the rules of this is that we can't use a number more than once, so I can't use any more 5s or 15s or 13s, so I can only use that number that one time. So I've got to just kind of like a Sudoku game and just start piddling with the numbers and figure out what it is I'd like to put in there next. And I know it's probably not going to be, especially this one's going to have some small numbers in here because this is already a 19, so I'm not going to have another number that's that big because that wouldn't work. So when you go to work this for students, you're going to put in a number that's probably going to be wrong, and that's okay because that's just what happens. So let's just put in a number here, like let's say if we chose this to be the number 11, let's just see what would happen if I would do that. And if it works out fine, and if it doesn't, that's fine. Now I'm going to put it in a different color, because I know that the 19 is right. So if that's 20, then that number here would then need to be so that I would have it all the way across, equaling 33. That would need to be a 13, but that's not possible because I've already have a 13 there, so that's not a good one to pick. Alright, I chose an 11. I can't really pick any of these numbers that are up here. I have to pick a number that's different than that. So I'll just pick a 7, see how that does. 9 and 7 are 16, and if I do 33 minus 16, that's going to be 17, and no other 17, so that's okay. So let's just go straight up and down. 15 and 7 are 22, so 33 minus 22, this one would need to be an 11. I don't know if that'll work. 19 and 11 are 30, and that would need to be a 3. So let's see if this adds up to a 33, and it does. Oh, I have a winner. So I'm pretty happy about that. This is a winner. And you just keep playing this game for all the rest of these. So you'll need to, in this one, come up with a number, and it's going to be a bunch of guessing and checking, and that's really okay. You're just going to put a number here that's not one of those, and then see what's going to happen as you keep going around the circle up and down. So let's just pick something at random. I don't know. Let's just choose 12, see what that does. I like that just because 14 and 16 are 30. So I made a 30. So if that's a 30, then let's go across. That would be a 12. So this would need to be an 18. This right here, if that's 16 and 8 are 24, so that would need to be a 6. If you're 16, you would need to be a 14. I don't have any violators yet, do I? Nothing's been repeated. Right, so that's 26. 26, that would need to be a 4. I wonder if that works. 18 and 8 are 26. Add 4. Oh, that's... Well, that was a winner really easy, wasn't it? But you can see it's still just a guess and check. But I probably shouldn't. That was pretty random. Anyway, I got lucky. So anyway, if you have any questions about 1.2, be sure and email me. And I can go through any of the problems for you like I've done here. All right, good luck with that homework.